Okay, YouTube, in this video we're going to practice expressing sets of numbers in what we refer to as interval notation. And basically, as a lead-in, what I want to kind of say is that we're going to be solving, instead of equations now, we're going to be solving inequalities. So getting statements, for example, like this one right here, in which we're going to want to express our set of answers, which is infinitely large, in a convenient way. So for instance here, if I were to say, all numbers less than or equal to 2, we're going to learn that we can express this in what we refer to in interval notation. And it's basically this interval of numbers right here would include 2, and all the numbers less than 2 would cause this to be a true statement. So how we express these is kind of explained on the left side here. So it says some sets of real numbers can be represented using interval notation. It says suppose that A and B are two real numbers, and all this tells us is that A is to the left of B on the number line here. But essentially, we could say that we have either open or closed intervals. You'll hear this a lot of the time. And open basically means when you look at this number line here, we say A is to the left of B. Perhaps I want to illustrate all of the numbers between A and B, but I don't want to include A and B. So you'll notice here, if you can read this, it says the parentheses in the graph and in the interval notation indicate that A and B, the endpoints, are excluded from the interval. So we would not include those endpoints, but everything in between we would include, whereas if we had brackets, now brackets is going to be referred to as a closed interval, and basically it means all the numbers between A and B, but also including A and B. So those are inclusive, and parentheses are exclusive. So maybe we write a note here, we say parentheses, we say exclusive, we exclude the endpoints, exclusive. And then we would say that if we have brackets, we're talking about something that is inclusive. Now what I'd like to do before we kind of move on here is basically tie this into what we refer to as set builder notation. So for this open interval from A to B here, we say the open interval from A to B, and this is how you write it in interval notation. You say parenthesis A, comma, B, parenthesis. So from A to B and not including those. We say it represents the set of real numbers between, but not including A and B. And as we write it this way, this is our interval notation here, it's not an ordered pair. We say that's the same thing in set builder notation as saying the set of all x such that A is less than x is less than B, where x is some number between A and B and not including A and B. So let's consider the closed interval. You'll notice that this time we say that the interval from A to B, we write it in interval notation thusly. We say A comma B, where we're putting brackets on either end. So we would say this really represents the set of all x values such that x is between A and B, but also it could be or equal to A or equal to B. So now two possibilities for intervals that I haven't explored yet are these two down here. We say the infinite interval A to infinity represents the set of real numbers that are greater than A. So we would say if we were to write in parentheses here A to infinity, we would say all real numbers such that x is bigger than A. And we can see this interval on the number line here graphed this way. So you see we have a parenthesis here, and then this is going to proceed to infinity on the right. That's an arrow that I drew there. So basically, we always include a parenthesis on infinities, okay? So whenever you have an infinity, we always use parentheses. So we'll make a little note here. Use parentheses at infinities. And the reason why is because infinity is not a number, so we can't include it. So we exclude it. Okay, remember we use parentheses. And then last but not least, you'll see this down here. It's an infinite interval, and I would write this as negative infinity up to and including B. You'll notice that on the B here we have a bracket. So in this particular instance, we're saying all real numbers such that x is less than or equal to B. We're saying all numbers including B and to the left, and we're not including infinity. So we put a parenthesis on that, negative infinity specifically. So keeping in mind, parentheses indicate that the endpoints are not included, and we say square brackets indicate that the endpoints are included in the interval. And note here, parentheses are always used with negative or positive infinity. So what we want to do in this particular instance is basically graph all of these or represent them in set builder notation. Before we do that though, what I want to point out is that there are 9 types of intervals used to describe the sets of real numbers, and these are the only intervals we can think of, but looking at these we would say that the open interval from A to B basically means starting just after A and going up to just before B but not including A and B, whereas the closed interval from A to B, we'd say bracket A to B bracket. This is x is some number between and including the endpoints there, a to b, we could have an inclusive on one side and exclusive on the other, both ways with a and b here. So you'll see that we have a bracket here but a parenthesis here, and then vice versa is true on this one here. We have a bracket on the right side and a parenthesis here. We would exclude that. So here come our infinite sets. We would say all numbers greater than a, or all numbers greater than or equal to a if we have a bracket here. And we say in set builder notation, we say all x such that these things are true about it. And likewise with b, if we said less than b or less than or equal to b, that's what these two are indicating here. And last but not least, we say that this right here, this would basically be all real numbers, because we're saying it's the interval on the number line that starts way out at negative infinity and goes all the way to positive infinity. That's that interval of numbers we're using. So up here, what we want to do is express each of these in set builder notation, and then what we're going to do is graph these sets. So I notice here that we have an interval from -2, and it includes -2, and it goes out to but not including 5. So in set builder notation, let's start by expressing this in set builder notation. I would say that x is some number between -2 and 5. So I'm going to put a -2 here, and I'll put a 5 here. And we'll say that x is in between these. So because we're excluding 5, we say x is purely less than 5. But because we're including -2, x is greater than or equal to -2. That's what this would look like in set builder notation. Now, putting this on a number line, we're going to graph all of our solutions a lot of the time. And so we'd say 0, I'll go 1, 2, 3, 4, 5. Label this 1, 2, 3, 4, -5. And to sketch this, it's really kind of a simple thing. We just write it the same way we do our interval notation up here. So at -2 here, I'm going to put a closed bracket. We say we are including this, and then we're going up to but not including 5. And so to graph this, it's just this interval of numbers right here that would be what we're interested in. So now this one here says it's a closed interval on both sides, excuse me. So we say from 1 up to 3.5. So again, we'd say in set builder, this would be all x such that x is greater than or equal to 1, but less than or equal to 3.5, this interval of numbers from there to there. And on the number line, okay, so we'll sketch this one out here. And because everything's positive, I'll say here's 0. We got 1, 2, 3, 4, and 5. We would sketch this as starting at 1 and including 1, and going up to 3.5, which would be about right here. This interval of numbers is what we're expressing here. And then last but not least, negative infinity up to -1. And we notice that we're not including a negative infinity, of course, but in this case, we're also not including -1. So we'd say in set builder notation, this is essentially all x values such that x is less than -1 is what we would say here, purely less than -1. So we would say, here's what it looks like in set builder in terms of what it looks like as an interval on the number line. We'd say, here's 0, here's -1. I'll label this. We're basically saying all numbers not including -1 and also to the left of -1. But we read this left to right. So we say starting way out on the left and going up to but not including -1. And in the next video, we'll talk about how we can find unions and intersections of sets in interval notation.